Welcome to module 47 of Database Management Systems course in the IIT Madras online BSc program. We have started discussing about transactions, that is doing some changes work in the database. We have defined transactions, their states, and the basic concept of concurrency, where more than one transaction could operate on the same data items at the same time. And we have with that seen that a certain schedule of these instructions coming from different transactions seem to be valid and certain are not. Some are serializable, some are not serializable. And all schedules may not satisfy the basic acid properties of transactions, that is atomicity, consistency, isolation and durability. So, moving on, we will now take a closer look in terms of how transactions can work concurrently, what is the serializable behavior, what are the conflicts and so on, and talk about serializability and conflict serializability. Serializability is we start with the assumption that each transaction preserves the database consistency. This is a basic assumption. If a transaction by itself has a logical error, like if we have read A, then we have A assigned A minus 50, write A, then we have read B, B assigned B plus 40 and write B. This is a valid transaction, but I have reduced A by 50 and increased B by 40. So, A plus B here will be less by 10, right. That has got nothing to do with concurrency or anything. This inconsistency is due to a fallacious transaction. So, we are assuming that such transactions are not there. So, a serial transaction execution of the set of transactions will always preserve the consistency, because if every transaction is preserving consistency, then if I do them one after the other, they will preserve consistency. A possibly concurrent schedule which mixes the instructions from multiple transactions is said to be serializable if it is equivalent to a serial schedule. If it produces exactly the same data values as some serial schedule, if that can happen, then the concurrent schedule is called serializable. And there are two notions for serializability, one is conflict serializability and other is view serializability. So, just to recap these examples, you should look back that we had shown in the last module that there is a schedule 3 which is serializable to schedule 1, because it is equivalent to schedule 1. So, as we had seen that schedule 1, 2 and 3 are serializable, we also saw this schedule 4 which is not serializable, because it does not preserve the sum of A plus B, because the A written here is overwritten here and the B written here is overwritten here, resulting in a total sum which is actually just 260, 40 less. So, we concluded that all concurrent schedules are not serializable. So, these are just examples we had. So, now to talk about serializability, let us make a simplified assumption. See, in the database, in terms of database consistency, what are important is what you read and what you write. Everything else that you do with the data, as to how, after reading what computations you do and what you want to write, in between whatever computation you do is not a matter of the order in which you do things, because that is a matter of logic. That is a matter of pure and simple logic, and the read write is what would affect the consistency of the database, unless, as I said, unless there is a logical error in a transaction, that is a different thing, right. So, we will assume that schedules consist only of read and write, do not look at the rest. Now, we say suppose there are two transactions, Li and Lj, two instruction Ii and Ij, and from transaction Ti and Tj. So, Ti is a transaction, Tj is a transaction, Ii is some instruction there, Ij is some instruction in this, right. This is the situation. Now, we will say that there is for some data item q which is accessed by both these instructions Ii as well as Ij, we will say that there is a conflict if at least one of them write to q. So, we say the first one both are reading. So, does it matter in which order they read? It does not, right. If I just looking at these two, so they do not conflict. But if any of these, if one reads the other writes, one writes the other reads, if both write, then it does matter who goes first and who goes second. So, they conflict, right. So, any two instructions from two transactions, if any one of them is writing which a data item which the other is reading or writing, then there is a conflict between these two instructions. And so, in a serial schedule Ti Tj or Tj Ti, I will have either Ii going first before Ij or Ij going first before Ii, but I cannot mix them without having this conflict. Now, at this point it will be good to note that if Ii and Ij are consecutive in a schedule, then they do not conflict, right, because their result will remain the same even if they are interchanged. Okay. So, let us talk about conflict serializability. We say we have a schedule S and we want to transform that to a schedule S primed. And what is the process of this transformation? Doing a series of swaps of non-conflicting instructions. If there are non-conflicting instructions, we can swap them, change their temporal order. So, in that process from S, if we produce S prime, then we say that S and S prime are conflict equivalent. S and S prime are conflict equivalent. Now, we will say that schedule S is conflict serializable if it is conflict equivalent to a serial schedule. Serial schedule is one where first one transaction, then the next transaction. This is the basic concept. So, we will have to see what is conflict serializable and what is not. Let us take an example from the earlier one itself, that we have a schedule given here which does read write A, then T2 does read write A, read write B, read write B, this is. So, we can see that this write read in T1 and this write in T2 are not conflicting. Why? Because they are writing to reading and writing to different data items, which means I can swap these two. Swapping these two means this goes up, this comes down. Once I have done that, then I look at these two. These are also not conflicting because as it is both of them are read and they are from different locations. So, I can swap that. Then I can look at write B, write A, two different locations I can swap them, write B can also move up. Then I can look at write B and read A, different locations that can also move up. If it does, after these swaps, this is what I get. In every case, I swapped non-conflicting instructions only. Now, what is this? Here all instructions of one transaction is first T1 and then T2. So, this is a serial schedule. So, which says that tells me that schedule 3 here shown is a conflict serializable schedule. That is, by swapping non-conflicting instructions, I am able to convert schedule 3 to a serial schedule, schedule 6. So, that is the conflict serializability. Now, obviously, there are several schedules which are not conflict serializable. Look at here, read A, read Q, write Q, and this does write Q. You cannot move anything. This is a direct conflict here. In fact, you are unable to swap instructions to either get a serial schedule T 3 T 4 or a serial schedule T 4 3 T. So, this is not conflict serializable. Now, let us say how some schedules are bad and some schedules are good. Let us take two transactions, accounts only, but little different now. Update accounts, balance is balance minus 100 for account ID. So, this clearly says that 31414 is withdrawing 100 rupees from her account. This is transaction 2, which is crediting every account with 0.5% interest, right. So, there is no where clause. So, it will happen for everybody. Balance is balance time 1.005, which means by 0.5% it is given to everyone. So, this is transaction T1, this is transaction T2. Read A, write A, this will happen for all accounts. So, let us say there is other than A, there is another account B, right. There could be several others, but just for illustration we assume that there is another account B. So, it will have read A, write A in transaction T1 for this. It will have read A, write A for transaction 2. It will have read B, write B for transaction 2 again, right. Now, if we do a schedule like this, read A in transaction 1, then read A in transaction 2, write A transaction 1, transaction 2, then the will that give me a, is this schedule serializable? Right. So, suppose we have this 100 rupees in A and 200 rupees in A and 200 rupees in B. Now, if I do serially, if I do this schedule, then what will happen? I am doing W1A, that is write in A based on what I have read, which is 200, right, after doing a deduction of withdrawal of 100 rupees. So, this will be 100 rupees. But what I am writing here by W2, which I am doing next, is based on what I read in A and given the interest. Read in A was 200, given an interest of 0.5%, that is 1 rupee. So, W2 will write 201, B will have an. So, you can see that this is not, why is it not serializable? Because this is causing disaster. I have taken out 100 rupees from the account and then I end up having 201 rupees, right. So, the bank is going to get bankrupt very easily, right. So, this is S, you can easily see, is not a serializable schedule. So, what are the ideal schedules? Ideal schedules would be one after the other, first T1 then T2, or first T2 then T1. So, you have to see anything which is serializable has to be equivalent to one of them. Right? And we saw S is not, we can try out some T, where what we have done from S, the order of W1, W2 we have changed in this, and you can see the effect here. You can again see that B is okay, but A is getting less now. A should, after taking out 100 rupees, it should get an interest of 0.5%. So, the valid values for A are 100.50 if you first withdraw and then give interest, or it is first give interest. So, then it is 101 and then withdraw. So, it is 100. So, these two by the schedule, these are the two possibilities, right. But here you are ending up with different other values. So, T where you have changed another schedule T where you have changed this is also not serializable. So, neither S nor T are serializable. These are bad schedules. To answer the question that is it actually, does there exist a non-serial schedule which is serializable? Yes, it does. Suppose we credit interest to A first, then we withdraw the money, and then you credit interest to B. Right? So, credit interest to A first is R2A W2A. So, it starts with 200, it becomes 201. Then you withdraw money, it becomes 101, then you give interest to A. Perfect. Right? So, here it is a concurrent schedule which gives the same effect as a serial schedule. So, how do you get there? If I have this schedule, how do I say that this is conflict serializable? I say look at every individual W1 A and R2 B, these two, they can be swapped. Then W1 A and W2 B, that can be swapped different. Then R1 A, R2 B can be swapped, and every time you are seeing what goes on here. And finally, R1 A and W2 B. If you do that, you get the whole of T2 first and then your T1, which actually gives you 101 rupees in the account of A. So, this is your schedule 2, which is a serial schedule. So, you can see that any schedule, every schedule you may not be able to serialize. Every concurrent schedule is not serializable, but there are concurrent schedules which were serializable, and conflict serializability is actually trying to tell us that. So, the final question is obviously, if a schedule is conflict serializable, it is obviously serializable, right, that is no. But so, conflict serializability is a sufficient condition, but if does there exist serializable schedules which are not conflict serializable? Yes, unfortunately there does. For example, look at this. There are 3 transactions, W1A writing A, W transaction 2 writing A, transaction 2 writing B, transaction 1 writing B, transaction 3 writing B, right, all writes. Now, you cannot perform any swap here. You cannot swap these two, they are working on the same data. You cannot swap these two because both are from the same transaction and they are in this order. So, we cannot change order of instruction within one transaction. So, you cannot swap them. You cannot swap these two, again the same data. You cannot swap these two working on the same data. So, none of these, there is no swap possible. Right. So, this schedule is not conflict equivalent to anything, since you cannot do any swap at all, and certainly not a serial schedule. But the question is, does a serial, is it equivalent to a schedule as such? Now, you can just, I mean, this is now plain logic. You can see that every time it is writing, there is no read. So, nobody has used that reading value. So, if I do the writes of T 1, then the writes of T 2 and then the write of T 3, nothing changes, right. Nothing will change, because I get the, what is the final effect that I will get in doing this. A will be what has been written here and B will be what has been written here. Here, if you see, after this A has not been written, so A will be what is written here and B will be what is written here. So, in this order, which is a serial order of T 1, T 2, T 3, you will get the same result as that concurrent schedule given here. But this concurrent schedule is not conflict equivalent to anything, not to this serial schedule. So, it is serializable, but it is not conflict serializable, right. So, the basic point is, if something is conflict serializable, then it is necessarily serializable, but not the other way around. Something, a schedule could be serializable, but may not be conflict serializable, but such examples are rare. Now, the question is, how do you do this in an organized manner, right. So, how do you do this swap and thing in an automated fashion. So, what you do is you represent this in terms of a graph. This graph, the nodes of this graph are transactions, and if it is, if there is a conflict from one transaction to the, between two instructions of two transactions, then you draw an arc from one transaction to the other, where T I accesses the data item on which the conflict is existing. Right. You may label the arc by the item on which the conflict actually happened, and this is known as precedence graph. Why precedence graph? Because this tells you the temporal order in which things have to happen. So, this is the representation of the schedule in terms of the transactions and their conflicts, right. Now, we are making the algorithmic statement that a schedule is conflict serializable if and only if its precedence graph is acyclic. If the precedence graph does not have a cycle, then it is obviously conflict serializable. Why? Because if it does not have a cycle, then I can always go in the order, in the topological order of items of transactions, and that will be valid, and that gives you finally a serial. So, the topological sorting of the acyclic graph will give you the serial, the order in which the transactions transactions will produce the effect. Right. So, that is the basic model that we use. If you are not clear about topological sorting, how it is done, I would advise you to read up the algorithms book. It is a very standard breadth first technique to do that, and it can happen in it can be done in, if there are n transactions, it can be done in order n squared time. There is a better algorithm which does n plus e also, but even n square is fine, because usually the conflict graphs are not very large. So, this is the process by which you do that. You read this, understand, but I will just walk you through an example for better understanding. So, this is a schedule given. So, we have data item A, B, C, D, E, 5 data items and 5 transactions. Right. So, we have start with an empty graph with vertices. Now, you have W A being written, and it is being read by transaction 2 T 2. So, we will have an edge T 1 2. So, whatever T 1 writes is what T 2 reads. So, T 1 has to write first. So, that gives you this edge. We go to R 2. There is no further reference of A. So, this has no effect. Then we have W 1 B. W 1 B is read here. Right. So, whatever transaction 1 writes in B, transaction 4 reads. Right. So, transaction 1 has to precede transaction 4 in terms of this. W 3 C, transaction 3 writes and transaction 2 reads. So, 3 to 2, you have this. Then there is nothing else on B, there is nothing else on C. Now, W 2 D is read by transaction 5. So, you have 2 to 5. Then finally, you have W 4 E, what is written by E by in transaction 4 is overwritten by transaction 5, and you are done. So, what you have got that this transactions, this schedule has a precedence graph like this, and you can clearly see that this is an acyclic graph. Since this is a acyclic graph, we can sort it by topological sort. For example, one topological sort could be T 3, T 1, then T 2, T 4, T 5. There could be different sorts. For example, T 1, T 3, T 4, T 2, T 5 is also another. So, actually this is equivalent to a number of different serial schedules, but we just need one. Right. Even we do not need to produce that, but the fact that this precedence graph is acyclic tells me that this schedule is conflict serializable. And if you actually follow these precedences, you will be able to generate that sequence also. In the previous slide, actually this process that we executed here is written in words, which is a little bit more difficult to understand. So, I focused on the example. You can now go back and read it. So, this brings us to the end of this module. We have discussed about the concurrency issues of 2 or more transactions and the need for serializability, and learned that there are 2 types of serializability, conflict serializability and view serializability. And we have specifically discussed about conflict serializability with the conflicting instructions and the properties that a schedule has to have to be conflict serializable. We will continue on this in the next module. Thank you very much for your attention. See you in the next module.